Alright, so what we have decided so far is that the octagon's angles are 135, and so when we cut it in half, it's 67.5. I'm going to draw this triangle a little bit bigger just to make it easier to see. So we know that this angle is 67.5, and we can find this because this piece right here is half of the side, right? What's half of 7.7? 3 point what? 3.85. Okay. Don't round these. I know both of them are decimals, but they're exact, so don't round those. This right here would be the apothem. Right here, we need it to be able to plug into our formula because we can easily find our perimeter on this one. Because you have how many sides again? 8. So 8 times 7.7 will give our perimeter. So we don't need that. We need the apothem. So as Landon just said a second ago, we're going to use tangent because we've got the side that's adjacent and the side that's opposite. So tangent of the angle equals opposite, which is our apothem, over adjacent, which was the 3.85 y'all said.
Tangent of 67.
Okay. How do I get rid of the bottom of the fraction again? Multiply. So if I do it on this side, it's just to cancel it, but I got to do it on this side to keep it balanced. I'm sorry, I squeezed that in there a little bit. So type in 3.85 tangent 67.5. Type that into your calculator.
9.97. It goes on.
3.85 tan 67.5.
Rounded 9.3.
9.3.
Okay. Now that's, just keep that in your calculator, don't clear it. Because yes, I wrote the rounded 9.3, but remember, just keep the actual answer in there. Okay, we have 1/2 of our apothem times our perimeter. Oh, it died. Somebody just must have not pushed it in. Sorry about that. Okay, so you all already have, those of you trying, already have this number, not the rounded, but the original in your calculator. So do times 8.
8.7 or just 8?
That's not 8.7. It's just 8. No. This number that you have in your calculator times 8.
75.
Okay. Now do times 7.7.
Exact answer.
I just want you to do it first. 7.7.
572.554.
Okay. Now we half it, so divide by 2. You didn't just retype that, did you? That's why I keep telling you not to retype it. Keep the answer in there and just hit divide by 2. Because every time you retype it, if you don't type every digit, you're rounding. And even if you type every digit, your calculator will only show you so many. It kept going. That's why I said let the calculator do the work. Okay? What do y'all get?
286.27.
I left the calculator.
286 point what?
27.
Nearest tenth.
Oh, 0.3.
So 0.3.
Most of the
Okay.
time, I don't even solve for X. So
Are there units in this problem?
yes.
What are they?
They are.
Units squared.
Yeah, units.
If there's no units in the problem, just put units squared. So this is our answer. Okay. So that's number 6. Do y'all want me to tell you which ones haven't been done?
Yeah.
Okay.
You do number 9.
It's been done.
I don't.
Landon, that's not my issue. Just because you don't want to doesn't mean that it's not there. We have not done in any class period number 1 or 2 or on the back 11 through 15. We haven't done any of those.
Can we do 14? Because there is nothing.
14 is the easiest one on the page. Look closer.
Oh, yeah, it's just a square.
Just a square. I will do it if you want me to.
Oh,
15?
15.
Okay.
But 13 is easier than a square.
No, it's not because you don't have the height. You can't possibly have a regular polygon easier than this one. Okay?
So then just do the triangle.
Yeah, because there wasn't units in the picture, so sorry, right here. This is what we got. 286.3 units squared. I'm sorry, that was on number 6. Did y'all say 15?
Yes.
Okay.
Wait,
All right.
I
So,
thought it was an exact answer.
what was?
Number 6. There was only 3 decimals then cut off.
It doesn't make it an exact answer. Anytime you use trig, you definitely will not have an exact answer. Unless, about half the time, if your answer was, or your angle was a 30, a 60, or a 45, about half the time you'll get a whole number, or an exact answer. But if you're not using a 30, a 60, or a 45, you absolutely cannot get a whole number. Not doing trig. Okay? So on 15, this is a triangle, so what are our angles?
60, 60, 60.
Yeah, they're all 60. So when we draw our apothem here, we know that's a 90, but what happens here when this angle was cut?
30.
It's a 30.
it's
So
59.
this one's going to be a 30, 60, 90, which actually makes it easier than doing the trig, as long as you either know, or we'll go back and look at what your rule is for 30, 60, 90. What's across from the 30 and the 30, 60, 90?
2x.
No, you're right the first time. Yeah, x. What's across from the 60?
X to the power. X to the square root. Cube root.
X square root of 3. That's how you say that. X square root of 3. Or if you want the longer version, you can say x times the square root of 3. But there's no cube root. None of that exists. I mean, it exists in math, but it doesn't exist in this problem.
What?
Okay, and then across from the 90 is what? Our 2x. So in this case, yes, we could have done trig. We would have had to do sine and cosine because we don't have the apothem or the part of the side. It's much easier to use this way. So if 2x is 8, what's x? 4. And if x is 4, I can put a 4 here. Now remember, that's just for this piece.
6 point.
No, just leave it for a second. Let's not round when we don't need to. This is an exact answer.
6.982.
No, that is a rounded answer. This is an exact answer. Okay, the thing I just said. That's only from here to here. So what's the whole side length? If from here to here is...
8 square root of 3.
Yeah, 8 square root of 3. So all of our sides are 8 square root of 3. So what's our perimeter then if I have 3 sides that are each 8 square root of 3?
8 square root of 3 times 3.
So 8 times 3 is what?
24.
So we got 24 square root of 3 for our perimeter. We have our apothem is 4. So when we put it into the formula, this one's easier. You got half times 4 times 24 square root of 3. What's half of 4?
What's half of 4?
2. What's 2 times 24?
48.
So if the directions didn't say to round to the nearest tenth, this is an exact answer. But plug it into your calculator now. 48 square root of 3.
83.1. Oh, 41.3.
What's after the 1?
3.
Yep, then 83.1 is right. And then there's no units, so just put units squared. So that was a good one to pick because we hadn't, in here, we hadn't done one that we didn't have to do trig yet. Okay. Y'all want to pick one more? We haven't done 1, 2, or 11 through 14.
11 14 is
I said one more.
I guess just do 11.
11 is a what shape?
It is a
1, 2, 3, 4, 5, 6, 7, 8.
it's a heptagon.
Heptagon. So that's a good one to pick because that's the one that's not as familiar. We don't use heptagons or septagons, whichever name you choose, as often. So looking back at your angles for the polygons, what is the angle there? It's one you're probably not going to have memorized because it's the weird one.
Let me look at my filing cabinet of things. 128.6.
Yeah. This one is already rounded. Okay? Remember, that was the angle out of all the ones from 3 sides to 10 sides. That was the only one that didn't work out to a whole number. And we have rounded it because it's actually like 0.57 something, something, something. So just be aware that this is already a rounded answer, so try your best not to round until the last step after this because your error would be a lot bigger, okay? So when I draw, focus y'all, when I draw the radius, what does that angle become if I have to half this?
128 times 64.3.
64.3. Okay, that's the angle we're using for this problem. Can y'all stop? We have the apothem. We need the side. Okay? That's still adjacent and opposite, so we're still using tangent. I told you you're going to use tangent about 90% of the time. Obviously, that's an estimate, but it gets used way more than any of the other things. Just a reminder, the only time you could even use a 45, 45, 90 is in a square. Okay? The only time you can use a 30, 60, 90 for this is in the triangle or the hexagon. Everything else you're going to have to use trig, and it's almost always tangent unless they gave you the radius. Okay? That's why I said about 90% of the time it's going to be tangent. So we got tangent of 64.3, and it equals opposite over adjacent, which I'll call x because that's the one I don't know. So what do we do? Yeah, we multiply by the bottom number on both sides. Okay? Now, it's nicer when the bottom number's a number and not a letter. It saves a step, but remember, if you have the letter over here now, you divide to get it alone. Okay? So in your calculator, type in 11 divided by 10, 64.3.
5.17, so 5.2.
Somebody verify?
I verify that.
11 divided by 10, 64.3. Okay, see, that's why we verify, because got two different, somebody, a third person. 11 divided by,
6.8, not 6.3.
it's not 6.8 or 6.3, it's 64.3.
No, I meant I put 64.8, not 64.3.
Can y'all listen? 11 divided by 10, 64.3. You say 10?
5.23. I mean 29.
Isn't that what he said the first time?
I said 5.17 because I accidentally put in 64.
What'd you get, John?
5.29. 5.29 is what I got when I fixed it.
Okay. So it was real close the first time. Okay.
I was off by 0.5.
Now remember, that's not the side length, that's half of the side length. To get the side, you double that. But don't type in 5.3 times 2. You already have this number in your calculator, just hit times 2.
So then 10.6. That's rounded.
10.6.
Yeah. But again, keep that in your calculator. Do not retype 10.6. That's the side length. So when we go to do our area formula, half times A times P, how many sides do we have? We have 7 sides, and we now know each side's about 10.6. So in your calculator, you already have the real, like, not rounded answer for 10.6.
So
Type in times 7 times 11 divided by 2.
107.6 units squared.
What's after the 6?
Units squared.
Okay. No, I meant what you said, Tristan. But you're both right, because technically I didn't say whether I meant the decimal or the units. So they're both right.
What? Is 13, can we assume that that's all 60s? 66?
It has to be. The name of this assignment is regular polygons. So it's not an assumption, it's told. That the regular polygons, every side is the same, every angle is the same.
So then,
Okay?
right here.
All right. So remember, the ones we did together are not the only ones that you have access to. We have access to the ones the other classes did together too. Do y'all remember where they are?
No. Just kidding.